Welcome to Unit 8, Section 5, Lesson 1, Video 4, Semi-Regular Tessellations. In the previous videos, we've seen some shapes which tessellate, both regular and irregular, and some shapes which do not. In this video, we're going to look at a shape called a semi-regular tessellation. The first question we'll look at: does a regular octagon tessellate? If you remember back to the very first video, we discovered that a regular octagon will not tessellate. The interior angles of an octagon are 135 degrees. If we look at the sum of the angles around a vertex, we see that the two octagon angles add up to 270 degrees. In order to add up to 360, we would need another 90-degree angle, right here. In fact, if we were to include a square as part of this tessellation, now we can see that the entire shape would tessellate because now we no longer have any gaps. So an octagon and a square can combine to form a tessellation. The entire tessellation would look something like this. We call this a semi-regular tessellation because it is a combination of two regular polygons. What other combinations tessellate? Let's look at a dodecagon, which is a 12-sided figure. The following table shows the interior angle measures for various polygons. A dodecagon has an interior angle measure of 150 degrees. We can also see from the table that a hexagon is 120 degrees, and a square has an interior angle of 90 degrees. If we add these three interior angles together, we notice that they actually add up to 360 degrees. That means if we were to combine these three shapes together, so that at each vertex there is a square, a hexagon, and a dodecagon, the three angles will add up to 360 degrees, and we would be able to create a tessellation such as this. What other combinations can tessellate? Let's look at our table once again. This time let's take a hexagon, which is 120 degrees, a square, which is 90, and a triangle, which is 60 degrees. If we add one triangle, two squares, and one hexagon, we notice that it adds up to 360 degrees. That means if we create a combined shape so that at each vertex there is one hexagon, two squares, and one triangle, like this, the angles around the vertex would add up to 360 degrees. We would be able to create a tessellation such as the following. And once again, at each vertex we have one hexagon, two squares, and one triangle. What other combinations tessellate? Let's look at our table. If we take a decagon, which is a 10-sided figure, the interior angles are 144 degrees. The interior angles of a pentagon are 108 degrees. If we add one decagon and two pentagons, it adds up to 360 degrees. And the shape would look like this. At each vertex, we have one decagon and two pentagons. The angles do add up to 360 degrees. However, when we try to tessellate this shape, it starts off working pretty well. When we continue with the tessellation, we actually notice that we cannot tile the plane without having small gaps like this throughout the diagram. So sometimes, even though the three angles around a vertex add up to 360 degrees, that combined shape will not tessellate and it will not tile the plane. Please proceed to the activities for Lesson 1.